In this video, we're going to introduce the law of cosines, and much like we did with the law of sines, in this video, we're going to derive the law of cosines, and in the video after that, we'll look at some examples. So once again, we have our triangle ABC, where the angle is opposite the side with the same name. And here we have from A to B, it is the length of side C, but when we draw an altitude, it's actually going to create two smaller segments. So drawing an altitude in our triangle creates two smaller segments. This one we'll say has a length of X, and this one has a length of C minus X. So for instance, let's say the distance from A to B was 10. If X was 4, then the rest of it would have to be 10 minus 4, or 6. So whatever this is, the remaining part of it is the whole thing, C minus X. It's just segment subtraction from geometry. Now, because we form these two right triangles, we can apply the Pythagorean theorem both to this triangle, right triangle on the left here, and this other right triangle that's on the right. So for the right triangle that's on the left, we get x squared plus y squared equals b squared. For the triangle that's on the right, we get c minus x, that expression, squared, plus y squared equals a squared. Now, in our first one, if we solve for y squared, just subtract x squared from both sides, we get y squared is b squared minus x squared. In our second equation, if we expand c minus x in parentheses squared and multiply it out, c minus x times c minus x, we end up with c squared minus 2cx plus x squared. So multiply it out if you don't believe me, but we get c squared minus 2cx plus x squared, and then bring down the y squared and bring down the a squared. Now, over here, we have this red y being squared is b squared minus x squared. That's the same y that we have over here that's also being squared. So we can substitute a b squared minus x squared in for this y squared. And that's what we have down here. So c squared minus 2cx plus x squared, and then plus the b squared minus x squared that we substituted in for this y squared, and it equals a squared. And if we combine like terms, the x squared minus x squared cancels out. So we have b squared plus c squared minus 2cx equals a squared. So again, keeping that same equation, a squared equals b squared plus c squared minus 2cx. Notice in our original triangle, we had a, b, and c, but in this one, we drew the altitude and we got this x. Well, this x, if we look at the cosine of angle A, the cosine of angle A is this x, the adjacent side, over this hypotenuse B in this triangle here that's on the left half of the picture. So cosine of angle A is adjacent x over hypotenuse B, which means if we multiply both sides by B, we get x is B times the cosine of A. And so what our law of cosines is going to look like is now we can substitute this b times cosine of A in for this x, and we get a squared equals b squared plus c squared minus 2 times c times b times the cosine of A. Now, based on where we drew our altitude, we could get one of three equivalent law of cosines. So the one we derived was this first one, a squared equals b squared plus c squared minus 2 times b times c times cosine of angle A. So I just switched the b and the c to make them in alphabetical order. But in general, it's any side squared equals the other two sides squared added together minus 2 times the product of those two sides times the cosine of the angle across from the side you're looking for. So with b squared, it's b squared equals a squared plus c squared, the other two sides squared and added together, minus 2 times the product of those two sides, so 2 times a times c, times the cosine of the angle opposite side b is angle b. So b squared is a squared plus c squared minus 2ac times the cosine of b. And c squared is a squared plus b squared minus 2ab times the cosine of c. So it's really just Pythagorean theorem with a little bit extra. Now, if we look at each of those different variations on the law of cosines, if we solve each one for the cosine of the angle, so get the cosine of A by itself in the first, get the cosine of B by itself in the second, and get the cosine of angle C by itself in the third, we get the following. So we get cosine of angle A is b squared plus c squared minus a squared over 2bc. with cosine of b, it's a squared plus c squared minus b squared over 2ac. And with cosine of angle c, it's a squared plus b squared minus c squared over 2ab. So again, we just solved each of those equations for cosine a, cosine b, or cosine c. And then to get what the angle measurement is, just take the inverse cosine of whatever you get on the right-hand side. So if you're looking to find the angle measurement, you can use these forms to help you. So in the next video, we'll look at some examples of using law of cosines. We'll also know when to use law of sines versus law of cosines. So thanks for watching. See you next time.